Have you ever stopped to wonder? Looked up on a clear day and asked yourself, why is the sky blue? It's a question that's puzzled people for centuries, sparking curiosity and inspiring countless scientific inquiries. From ancient philosophers to modern-day physicists, the quest to understand the sky's color has driven exploration and discovery. The answer lies in the journey sunlight takes, a fascinating voyage from a distant star to our very own planet. It's a journey that ends right here, as sunlight finally reaches our eyes. On Earth, under normal conditions, we are greeted by a beautiful blue sky, a familiar and comforting sight. But venture into space, and the sky transforms dramatically. There, the sky is pitch black, an endless void, even with the sun shining in all its glory. The secret to this difference is our atmosphere, a crucial component that makes life as we know it possible. It's a thin blanket of air, a delicate veil that surrounds our planet and protects us from the harshness of space. This blanket is made of tiny molecules, primarily nitrogen, which makes up the majority of our atmosphere. And of course, oxygen, the life-giving element that sustains all living beings on Earth. These invisible particles, though small, play a huge role. They interact with sunlight in a special way, scattering its rays in all directions. And this scattering is what leads to the creation of the blue sky we see and love. Without this atmosphere, the scattering effect wouldn't occur, and Earth would look as dark and desolate as space, devoid of the vibrant colors we take for granted. So, what exactly happens when sunlight, in its radiant form, meets our atmosphere? That's the key to unlocking the mystery of the blue sky. Let's uncover the secrets of how this invisible layer, this atmospheric blanket, interacts with light. Let's explore how it transforms ordinary sunlight into a brilliant, breathtaking blue sky. Get ready for a behind-the-scenes look, a scientific exploration of the phenomenon that paints our sky blue. Prepare to witness one of nature's greatest shows, a daily spectacle that unfolds right above our heads. Sunlight, the radiant energy that bathes our planet, appears to our eyes as a pure, clean white. It seems like a single, unified entity of light, but it's actually a blend, a dazzling mixture of all the colors of the rainbow, a hidden spectrum waiting to be unveiled. It's a symphony of colors, all traveling together. Each color travels as a wave, a ripple in the electromagnetic field, each with its own unique characteristics. With red having the longest wavelength, stretching out like a gentle ocean swell, and blue and violet the shortest, compressed and energetic. These differences matter. They play a crucial role when sunlight hits our atmosphere, the protective blanket surrounding our planet. The tiny gas molecules in the air, the very building blocks of our atmosphere, are just the right size to interact more, to have a greater effect, with the short, choppy waves of blue and violet light, bouncing them around like ping-pong balls. Imagine running through a crowded room, a chaotic scene of people moving in every direction. Short, quick steps bump into more people, a constant barrage of collisions, then long, slow strides, which allow you to navigate with fewer interruptions. When sunlight reaches Earth, after its long journey through space, the atmosphere starts to separate these colors, acting like a giant prism. The long waves of red and orange mostly pass through, unimpeded, like VIPs sailing through a crowd, but blue and violet get scattered, bouncing off those air molecules in every direction. This sets the stage for the blue sky we see, a beautiful canvas painted by the sun and atmosphere. Sunlight's hidden rainbow is about to be revealed, its secrets unveiled before our very eyes. Let's see how this scattering paints our sky, creating the breathtaking views we often take for granted. Here's where the magic happens. Rayleigh scattering. When sunlight enters the atmosphere, blue and violet light are scattered in all directions by tiny air molecules. Red and orange light mostly pass straight through, but blue light gets bounced around the sky. Our eyes are more sensitive to blue than violet, so the sky appears blue, not purple. Every time you look up, you're seeing blue light scattered from every part of the sky. The air isn't blue. The scattered sunlight is. This is why Earth's sky is blue while space remains black. It's all thanks to the endless dance between sunlight and air. Now, imagine you're an astronaut venturing out into the vast expanse of space. Picture yourself tethered to your spacecraft, floating weightlessly, with nothing but the inky blackness surrounding you. The sun shines just as brightly, an intense, unfiltered light unlike anything you've experienced on Earth, but the sky around it is pure black, an absolute void that stretches out in every direction. It's a stark contrast to the familiar blue sky we know so well. Why this dramatic difference? Because space is a vacuum, an almost perfect emptiness. There's no atmosphere, no blanket of air like the one that surrounds our planet. Consequently, there are no molecules to scatter sunlight, to bounce it around and fill the sky with a soft, diffused glow. Light travels in straight lines, unimpeded and direct. So unless you look directly at the sun, with proper protection of course, or at a lit object reflecting that light, you see darkness, the profound and absolute darkness of the void. On Earth, the sky glows with scattered light, a beautiful, life-sustaining phenomenon. In space, only stars, distant suns burning fiercely, and planets shine against the void, reflecting the light they receive. The blackness of space isn't from a lack of light itself, because light is abundant. It stems from a lack of anything to scatter it, to make it visible from different angles. Our blue sky is a unique gift of our atmosphere, a protective and beautiful shield. Without it, Earth would look just as stark and empty as space, a barren rock exposed to the harshness of the cosmos. That's the dramatic difference, the breathtaking contrast between our vibrant world and the seemingly infinite black cosmos. Earth's atmosphere does more than give us air, it creates our blue sky and soft daylight. At sunrise and sunset, sunlight travels through more atmosphere, scattering blue away and letting reds and oranges shine through. This same scattering gives us fiery sunsets and gentle daylight. Our atmosphere protects us, regulates temperature, and fills our world with color. The blue sky is a daily reminder of the science that makes life possible. Next time you look up, remember the sky's color is proof of our planet's unique, life-giving shield. From blue skies to red sunsets, our atmosphere is always putting on a show. And that's why the sky is blue.